Hello everyone. Welcome to our NCE training course. I'm Jenny from NovaStar. Our training is starting soon and the topic is 4K solution. To provide you a good training environment, we sincerely suggest you to keep your audio on mute mode during the whole session. Please scan the QR code or click the link at chat room to sign in. If you cannot click the link, please copy and paste it to your browser. Feel free to leave your questions that are related to today's topic on the chat room. We will reply you later on the Q&A session. If you have any other questions that are not about today's content, please feel free to send an email to nce@novastar.tech. Now, let's welcome Darren. He is today's trainer.
I'm Darren. Welcome to our NC training. So you can call me Darren or you can call me Darren Wong because Wong is my family name. Or you can call me tonight. Sorry, no kidding. Okay, first I'd like to start with the introduction of NCE training to the guys who are not much familiar. The full name of NCE is NovaStar Certified Engineer, and we have trained more than 3,000 individuals all over the world since it started in 2014 by giving multiple courses and valuable chances to embrace the LED control system. And NCE courses enable you to operate and maintain equipment independently. Because of the new coronavirus, and this year we hold the training online. And this series, we're hoping more techniques could get knowledge and the certification even in this hard time. And this series, NCE, we will have 8 courses and a final examination. You could get online training certification if you sign in for 6 courses at least and pass the final exam. So at last, I hope all you guys can go to all the courses to make a good score. And as you can see from this schedule, this is our 5th course. So it's time to have a short review about the last 4 courses. So the first course is the basic knowledge of Nova control system, which Jenny shares some information about the basic structure of the LED control system and how we calculate loading capacities of the output ports. And later, Arnold showed us how to use Nova LCT to perform the basic screen configuration of our LED screen. And after that, we can make sure our screen can show the correct image. And Stan showed us how to set redundancy settings for our system. It's about 3 ways for set redundancy within 1 unit and set redundancy with multiple units, the cascading way and the non-cascading way. And the 4th lay showed us the application scenarios. We may have some multiple screens in one project. So if you want to adjust the screen brightness or realize monitoring all the screen status in one interface, we need to use a multi-screen management function. And today the topic is about the 4K solution. So I will share some information about the 4K solution design. And you can see for the last 3 courses, it's all about the troubleshooting. Okay, now let's dive into today's topic, 4K solution design. So as we know, the pixel pitch is going down all the way from 3.9 to 0.6, 1.5, 1.2, and even 0.8 or even smaller. As you can see from this picture, the same size screen now we have more pixels, so which means the screen resolution become much bigger and bigger. The reason is because the pixel pitch has become smaller and smaller. And the 4K screen seems more common in our daily life, daily project. And from this picture, on the top left, there is a yellow mark which showed you 4K 3840 by 2160. I think you may have some doubts about the 4K resolution. Actually, there are some discrepancies when people define the 4K resolution. If we talk about the real 4K, the resolution should be 4096 by 2160. But in live, the Ultra HD resolution, 3840 by 2160, seems more common, and it's also very close to the 4K resolution. So people usually use this resolution to represent 4K as well. And today, in my demonstration, my presentation, I will also use the 3840 by 2160 to demonstrate the 4K solution. Okay, now let's talk about it. Before we talk about the 4K solution design, I think we should know some information before we start a project design. So what is the necessary information if we start to make a project design for the customers? I think normally from my point of view or from my experience, there will be three necessary informations. The first one, what is the total resolution of your whole screen? So here, regarding the resolution, we are not talking about your screen dimension, because sometimes when we're doing the technical support, the customer will tell us, okay, my screen is how many meters high and how many meters wide. So actually what we want is what is a pixel in width and what is a pixel in height. Then we can get the total resolution of the screen. So the total resolution, why is that important? We can, from this information, we will know how many output ports or how many sending card we may use for this project. I may have some ideas about the sending card type, but I'm not very sure because I also need the second information to help me to confirm what sending card to use, which is what is a video source the customer will use. Because for different sending card or different controllers, we have a different video source input. So this will help us to give the correct answer to the customers. For example, if the customer told you, okay, in my project, I will have a camera, so I need the SDI input, then I will not recommend the M Control 660 to the customers. I may recommend the VX4S because the VX4S have the SDI input. So here's an example. And the third one is about additional requirement, because except the total resolution and the video source information, the customer may also have some other requirements like the low latency, long distance transmission, or auto brightness adjustment. So with all these informations, we can provide the customer the perfect project design. Okay, now let's see what options to make a 4K resolution project. Which device to use, and what is the system structures. So here, I divide the sending card or the controllers into three categories: the 1080p level, and the 4K 1K level, and the 4K 2K level. So with all these devices, we can realize to finish a 4K project, but the system structure will be different. So now let's see them one by one, how we realize a 4K project with different sending cards. The first one, we use a 1080p to splice a 4K. And here in this structure, the sending card I'm using is an M Control 660. And in this structure, there will be three channels. The orange one represents the control channel, and the yellow and the green one represents the video channel, and the blue one represents the output channel. And let's see them one by one. The first, we need to use a USB cable, connect the control PC to the first sending card. And the control PC also provide a video source to a 4K splicer. And don't forget, the control PC here have some requirement because it should capable to output the 4K resolution video source to the 4K video splicer. And the video splicer will split the video source into 4 parts and provide this video source to each of the sending card. And for the loading part, for each sending card, as you can see here, this one load the top right of the screen, and this one loads the top left of the screen, and this one bottom left, and this one bottom right. So as you can see, totally we divide the 4K screen into 4 parts, a 2x2 area. And in this structure, now we have a 4K control PC, and we have a 4K video splicer, and we have 4 pieces sending card, which is M-Control 660. And if we consider about redundancy, if we want to set the system back up, then we need to double the sending card amount. So we need 8 pieces M-Control 660. So now next, let's see how we finish the software part. So at the fourth course, they told us if we have multiple screens, we need to create more than one screen. So in the screen connection interface, the quantity of the screen here, we should select 4. Because now we use 4 M-Control 660 to load 4 parts of the screen. So we need to create 4 screens in the software. So the quantity of the screen is 4. Now in this interface, you have 4 tabs: screen 1, screen 2, screen 3, screen 4. And we use the sending card 1 with 4 output ports to load the screen area, a quarter of the screen, which you can think is the top right of the 4K screen. And the sending card 2 is the screen 2, and we load the top left. Sending card 3 with 4 output ports, we load the bottom left area. And sending card 4, we use we load the screen 4, which is bottom right area. So totally, we use 4 pieces Control 660 to load 4 parts of the screen. And please note here, with the coordinates, they all remains 0, 0. Because why we are not create one big screen, one big screen, and we connect the screen connection. We finish the screen connection with all the 4 pieces Control 660. The reason is, for the software, the screen connection part, the topology will influence the image mosaic. It will influence the video source coordinates if we finish the screen connections. But actually, in this structure, what we have is a video splicer and 4 pieces sending card. So the image mosaic will finished by the 4K video splicer. Is not finished by the sending card. So here, every sending card, we should remain the coordinates 0, 0, because the video splicer will tell the sending card, okay, what is the video source for you, and which part of the video source you should display. And what if we use an all-in-one controller? Can we simplify the system structures? The answer is yes. And let's see the system structures. So this is the system structure. If we use an all-in-one controller, here is a VX4S. And it's the same principle if we use a Nova Pro HD. They are all the all-in-one controller. So why we call it all-in-one? The reason is it's not just a sending card, it's also a video processor. So let's see how the system goes. The first, we use a control PC to connect the first sending card via the USB cable. But here, you may notice the control PC, we are not use a 4K one. We can just use a normal one, which can output the 1080p level video source. And between the sending card, the VX4S, we also use a USB cable to finish the cascading, because they are spliced a big screen. So we need to control all the devices at the same time for the brightness adjustment. And for the video source part, and we need to use a DVI source input. Because as you can see, between every VXOS, we use DVI loop. So the video source should be the DVI. And we can loop the signal from the first one to the second one to the third one and the fourth one. And for loading this 4K screen, we also divide this screen into a 2x2 area. So this VXOS will load the top right of the screen, and this one top left, bottom left, and the bottom right. So for load the screen is the same principles when we perform it in M Control 660. And let's see the software settings. It's same principles. We create full screens. So you have full screen tabs in the screen connection interface, screen 1, screen 2, screen 3, and screen 4. So if you check the screen connection, it's basically exactly the same when you perform the system structure, when you perform the screen connection with the M Control 660. But you may wondering, in the previous structures with M Control 660, we are not set the image offset. The reason is we have a video splicer which can do this job. But now we do not have a 4K video splicer in the front. But why we still not set the image coordinates? Don't forget the VX4S is an all-in-one controller. It's a sending card and it's also a video processors. So it can also do the video processing functions because the VX4S or the Pro HD, we have a function named image mosaic. So the image mosaic will help you to splice several sending card and to splice to load a big screen. So after we finish the software part, it's not finished because we also need to do some settings in the front panel. And next, let's see the hardware settings. So this is the front panel of the VX4S because we need to use the knob button and the LCD menu to change some parameters and then finish the image mosaic. Let's see this short video clip together. So get into the menu, select image mosaic. As you can see here, for the image mosaic, we have two options. It can let you to do the equal image mosaic or unequal image mosaic. So for this example, we divide the screen in 4 parts. It's 2x2 area, and it's equal. Every sending card we load a 1080p area. So here we need to select the equal. But sometimes maybe you have 2 VX4S to do the splice. Maybe it's not equal. For example, one sending card load a much bigger area and the other one load a small area. So here it doesn't matter. We just input the total weight of the pixel to the head pixel of the big screen. So the total pixel here is about this the screen which you will splice for. So for example, for this case, the big screen is a 4K screen. So the total weight should be 3840 by 2160. And when the sending card is unequal, we should also input the load area weight and load area height. But here, for this case, we no need to do it because it's being divided into 4 equally parts. So let's continue. So we need to select equal. As you can see on the front panel, the menu has been changed. The mosaic row quantity shows here. So we input the total weight pixel 3840 and the total height pixel 2160 to let the controller know, okay, the 4K screen is the aim, is a target we need to splice. And we should tell the software, we should tell the controller, okay, how many rows and how many columns the splice we use. Sorry. So input the total width and the total height. And for our examples, the mosaic row quantity is 2. It's a 2x2 area. And the mosaic column quantity is also 2. So there will be 4 4 load area position, 1, 2, 3, and 4. And we should do it 4 times for every VXOS to let the sending card know, okay, you have 4 brothers, and you should splice this 4K screen together. And there is some logic when we do the image mosaic. For example, if this is our screen, and we divide it into 4 parts, and the image mosaic, this part is about the loading area position when we set the image mosaic. This will be the 1, 2, 3, and 4. So you should be careful when you set the image mosaic in the front panel of each VXOS. So the top left one, when you set the loading area position, it should be number 1. And the top right one, the loading area position should be number 2. And same principles. And if we have some other screen shape or screen structure, it's the same principles. So the number logic is from the left to right. And if we have more rows, it will start to the next, it will continue to the next row. 1, 2, 3, 4. Maybe we have 5, 6, 7, 8. So this is a system logic when we set the image mosaic and when we give the sending card the load area position. Okay, now let's continue. So let's have a short review about the steps for configure the image mosaic. The first, for the control channel, we use a USB cable to connect the control PC to the first sending card, and we cascade all the VX4S via the USB cable. And for the video source, it comes from the control PC, the DVI signal, and we use the DVI loop to the second one, to the third one, and to the fourth one. And we need to go to the software to configure the screen connection of each VXOS. And each VXOS is a separate screen, which means we need to create 4 screens in the screen connection interface. After that, we need to go to the hardware settings. So to the first VXOS, we choose the image mosaic, and we choose eco, and we input the total width pixel is 3840, and the total head pixel is 2160. And for the image mosaic quantities is 2, and the image column mosaic column quantity is 2. It's a 2x2 area. And the loading area position, 1, 2, 3, 4. So the logic is from the top left to top right, then go to the bottom left, bottom right, 1, 2, 3, 4. So we need to do it 4 times for every VX4S. So this is the system structure, and this is the software and hardware settings if we use a VX4S to splice a 4K. And you may be wondering what is advantages and disadvantages if we compare it with the previous structure. We use a 4K splicer and we use a 4-pieces Control 660. Okay, for the advantages part, if we use a VX4S, the first, we are not required for a 4K video splicer. And for the Control PC, we are not required the Control PC. It's a 4K one. So which means we can save some cost. But the disadvantage is also obvious. The first, we cannot realize the pixel-to-pixel display. The previous structure, the 4K PC provided 4K video source to the 4K video splicer, and it can provide 4 separate video signals to each sending card, and we can realize the pixel-to-pixel of the 4K screens. And we can, I think you can understand, for the image qualities, the best way is a pixel by pixel. So this is disadvantages if we use a VX4S. And for some application scenarios, the people or the customers may have some requirement to switch the video source and open multiple layers. But for the VX4S here, if we use DVI loop to be the signal for the raised VX4S, the video source input can only be the DVI. So which means we cannot to do the signal switch. And if we want to open layers, the VX4S only support picture-in-picture, and the picture-in-picture can only be opened within the loading area of that VX4S. But if we use a 4K video splicer and the full PCS M Control 660, we can support to open multiple layers, and these layers can cross different video VX4S, different M Control 660 loading area. And with a 4K video splicer, we can support to switch different video source input. So that is the advantages. So if you have a 4K project, and if you want to use a 1080p level sending card controllers to realize it, and we recommend you the first way with a video splicer and 4 pieces sending card. I think if we talk about the redundancy, all our sending card need to be the double amount. So maybe for our control room, it will be like this. I don't know what is your feeling. Every time when I saw this, it made me a headache. So can we, is it possible to simplify the system structures? The answer is yes. So we need to consider, okay, can we reduce the sending controllers number? Then we need to find a controller which have more output ports, have much loading capacities to load the screens. Then we are talk about the 4K 1K to splice the 4K screens. So with the 4K 1K, currently for NovaStar, we have the controller M Control R5, which have all the 4K 1K level video source input, and it have 8 output ports, can load the 4K 1K resolution screens. And let's see the data flow. The same principles, we use the USB cable, connect to the control PC to the first M Control R5, and the control PC also provide a video source to the video splicer. The video splicer will split this video source and provide separately video source to the first M Control R5 and the second one. With the M Control R5, we have three kind of video source input: the dual link DVI, the DP, and HDMI. The DP is 1.1, and the HDMI is 1.4. And for load the screen, the first M Control R5 will load top of the screen. It's 3840 by 1080. Sorry for the red part. This is not 3840, it's 2160. For the bottom one, we use the second M Control R5 to load the bottom area of the screen. And let's see how the software settings. In same principles, we go to the screen connection interface, and the quantity of the screen, we no need to create 4, we just need to create 2. And with the first M Control R5, we finish the screen connection of the top of the 4K screen. And for the bottom part, we use the second M Control R5, which is the screen 2. And with the image coordinates, we still remain it like 0, 0, because the 4K video splicer will help you to do the image mosaic. And you may wondering, I remember NovaStar have the 4K sending card. Why do we just use one device to finish this project? Of course, we can use a 4K. We can use a 4K to realize this project. So the system will be simplified like this: the control PC to the video processor, then go to the 4K sending card, then go to directly load the 4K screens. And you may wondering, or you have some doubts, why you still add a video process here? Because the 4K M Control 4K can accept the 4K video source input. The reason is, for some application scenarios, the customer, they may want to open multiple layers, or they want to switch the video source. Then we need to use the video processor to do this. So we use a USB cable, connect the M-Control 4K with the control PC. And the video source comes from the control PC to the video processor, then goes to the M-Control 4K. Then we can enable layers from the video processor part. And for load the screen, we use just one piece of M-Control 4K with 16 output ports to realize this 3840 by 2160 resolution screen. And you may be wondering, for the 1080p level, we have the sending card choice, M-Control 660 or M-Control 600. But with the 4K level, do we also have the all-in-one choice? And of course, we have another device, name is Nova Pro UHD Junior. So we can also use one piece Nova Pro UHD Junior to finish the 4K project design. As you can see, currently now, we do not use a 4K video processor anymore because the Nova Pro UHD Junior is just like an M-Control 4K and a video processor combined together. So the system structure will be like the USB cable to the Pro UHD Junior and the video source feed to the Pro UHD Junior as well. And we use the UHD Junior 16 output ports to load the screen. And if you are wondering about layers, of course, so for the Nova Pro UHD Junior, we also support open 3 layers and 1 background on the screens. So it's for the common 4K project is enough. And let's see the software settings. So this time, we no need to consider about multiple screens because we use only one device to finish all the screen connections. So here, the sending card number is only 1, and we no need to create 4 screens, only 1. And we use all the 16 output ports to finish the screen connection. So this part is not much to talk about. Okay, now let's have a review about the controllers we use today. The first, when we use the 1080p level to splice the 4K, we use M-Control 660 and a VX4S. So even the M-Control 660 is being released in the market for a long time, but it's still popular. I think the reason is because the front panel. Because we have the front panel and a knob button, we can realize the quick configuration with the front panel. And they support 2.3 million pixels, and the video source is HDMI and single-link DVI. For the VX4S, it's an all-in-one controller, combine the sending card function and the video processing function like the auto scale and the picture-in-picture. With the 4K 1K level, we use the M-Control R5. And you can see here, all the video source input is support 4K 1K resolution. The HDMI is 1.4 version, and the DP is 1.1, and we have one dual-link DVI, also support 4K 1K. And it supports free rotation. If you use the receiving card A8S or A10S Plus together with M-Control R5, you can realize the image rotation any angle of your screen. And it also has the fiber output ports, which can meet the long-distance transmission application scenario. Okay, then we just use one device, M-Control 4K, to load the 4K screen. And besides, the video source input is all the 4K 2K level. The M-Control 4K support 8.8 million pixels and also support like the 3D, HDR, and low latency. And also it have full fiber output ports, which we have another accessories named the CVD 4K. You can use this 2 devices together to finish the long distance transmission. And the last one, we talk about the 4K all-in-one, which is a Nova Pro UHD Junior. And except the HDMI video source input, the DVI will also support 2 different modes, the single link mode and dual link mode. And we also have the 12G SDI in and loop. And besides the 3D HDR low latency, the Nova Pro UHD Junior support open 3 layers and 1 background. And if you talk about the loading capacities, the M-Control 4K and Nova Pro UHD Junior, we all have 16 output ports, but the Nova Pro UHD Junior can support 10.4 million pixels. The reason is, for the M-Control 4K, it's just a sending card, no image processing functions, no scaling. So it's been limited by the video source input. 1496 by 2160. So if you multiply these two numbers, you would get the total resolution will be around 8.8 million pixels. But for the Nova Pro UH Junior, we can make full of use the output ports. So each output port is 650,000 pixels, and we can use 16 times this number, this value, because the Nova Pro UH Junior is also video processor, so we can scaling the video source input to the full screen to make our screen shows every pixel shows the image. And also it supports the fiber output ports. Okay, this is 5 kind of controllers we talk about in the 4K solutions. And the last, let's have a review about today's topic. So regarding the 4K solutions, if we use the 1080p level to finish the splice, we have two choices: the independent controller or the all-in-one controller. With the independent controller, we have the M-Control 660 or 600 or even 500, etc. Then we need a 4K output port, a 4K capable control PC, and a 4K video splicer. And we need 4 pieces M-Control 660 to finish this project. And if we use the all-in-one controller, like the VX4S or Pro HD, we can use the DVI as a video source input, and we can use the DVI loop to splice the image to splice the 4K screen. But the disadvantage is it cannot do the pixel by pixel display. So because the video source input is 1080p level, we will scale the 1080p to 4K. As you can imagine, the image quality may not that good. And when we talk about the 4K 1K level to splice the 4K, we have the independent controller, M-Control R5. We also need a 4K capable control PC, and we need a 4K video splicer, and we need 2 pieces M-Control R5 to load the top of the screen or the bottom of the screen. And last one, regarding the 4K 2K level, we also have 2 options: the M-Control 4K and the all-in-one Nova Pro UH Junior. So with M-Control 4K, if the customer just want one picture or one content on the screen, okay, that's enough. If the customer want more layers or want to show different content on the screens, we may need the video processors to do the source switch or to open layers on the screen. And if we use the Nova Pro UH Junior, we can also do this job, and with one device, it can support open 3 layers and one background on the screen. So this is the total topic about today. And if you have any questions, you can leave your questions in the chat room, and later in the Q&A session, my colleague Stan will answer this question. And what's more, actually on our official website, we have the online workshops. In the workshops, what you can get some new series videos. For example, for the software operation videos, we call it NovaStar course. You may find some information about how to do the smart setting for regular module and how we set the redundancy. You can have a look about this software operation videos. And we also have the product solution series videos, like the cloud-based platform solution and the stage render solution C1 and N9. So all these informations you can check on our online workshops. So the link is like here. Go to our official website, novastar.tech, support and training, and then NovaStar online workshops. Okay, so I think that's all for today's topic. And next part will be the Q&A session, but we need to around 1 minute to prepare everything. So during this time, please kindly fill out this feedback. See you later. Bye-bye.